intercept form practice. So these are just some practice problems, and here's the answer key to it. So I'm going to work these out step by step. First thing we're going to look at is the standard form of a quadratic function, which is y equals ax squared plus bx plus c, where a and b are coefficients and our c is our constant. Also notice that our c is our y-intercept value. It says create a table of values for the quadratic functions and then graph each quadratic function. On the graph, mark the locations of the following significant features of the graph: the axis of symmetry and the vertex. Then determine the key characteristics. So we're given the function y equals x squared minus 2x plus 6. So we're going to enter that in our calculator. And we're going to find some key characteristics here. So let's start off where x equals -1. So from our table, we've got -1, 9. Where x equals 0, y equals 6. Where x equals 1, y equals 5. Where x equals 2, y equals 6. And where x equals 3, y equals 9. So let's graph those points. So at -1, y equals 9. Where x is 0, y is 6. Where x is 1, y is 5. Where x is 2, y is 6. Where x is 3, y is 9. So we've got our parabola here. Notice that our y-intercept should be the same value as our c. So in this case, where x equals 0, y equals 6. Now let's identify our vertex. So because this parabola is opening up, so I'm going to go ahead and say that it opens up, then our vertex should be our minimum point. Just give me the lowest point on this graph, which in this case, the lowest point of this function is at 1, 5. So our vertex is 1, 5. And our axis of symmetry is going to pass through our vertex. So that's a line, the vertical line, that splits our parabola in half into two symmetric curves. So in this case, it's where x equals 1. And now it's asking for our x-intercepts. Well, this parabola never crosses the x-axis, so there are no x-intercepts, so we can just go ahead and put none there. All right, let's go to problem 2. It gives us the function -2x squared minus 4x plus 4. So we're going to enter that into our calculator, and we're going to look at the graph. So let's start at where x is -3. So when x is -3, my y value is at -2. When x is -2, my y value is at 4. When x is at -1, my y value is at 6. When x is at 0, my y value is 4. When x is at 1, my y value is -2. So let's graph those points. So where x is -3, y is 2. Where x is -2, y is going to be at 4. Where x is -1, y is at +6. Where x is at 0, y is at 4. And where x is +1, my y is at -2. So accidentally graphed +2 there. Very common mistake. So where x is -3, my y value should have been at -2. And there's our parabola. Notice that this parabola is facing downwards, so it's opening down. Looks like a bowl flipped over on itself. If I look at the function, our c value is at +4, so that means that our y-intercept should be at 0, +4. And if we look at our table, this is the case. If we look at our graph, it all works out. Now it's asking for our domain and range for this function. For all of the functions that we're learning this in Algebra 1 this year, our domain will always be all real numbers. So from -infinity, +infinity, or you can put all reals. And then our range is going to deal with our vertex. So first off, our vertex in this case is our maximum point. So our maximum point is at -1, 6. So I know my highest point for our range is going to be at +6, and it's going to include that value. So our parabola's range is going to be from negative infinity to +6. And make sure you do that as closed brackets. You can also put this as inequality form and say that y is less than or equal to 6. All right, let's move on to our third practice problem here. This tells us our function is -x² plus 2x. So let's start off where x is -1. So where x is -1, our y value is -3. Where x is 0, our y value is 0. Where x is 1, our y value is 1. Where x is 2, our y value is 0. And where x is 3, our y value is -3. So x is -1, our y value is -3, so 1, 2, 3 down. Where x is 0, y is 0, so that's our origin. Then for our next point, I'm going to go to the right 1 and up 1. Our next point is at 2, 0, so I'm just going to go to the right 2. Our last point is at +3, -3, so I'm going to go right 3 and down 3. So there's our parabola. So let's look here. First thing it's asking us for is our y-intercept. If we look at that function, it tells us y equals -x² plus 2x, and it's understood to have a +0. So our y-intercept should be where x is 0, y is 0, and that's true from the table as well, and we can see it there on our graph. Now let's look for our vertex. Because this parabola is facing downwards, our vertex is going to be our maximum point, which in this case is at 1, 1. And we can find our axis of symmetry now through that point. So it's going to be the vertical line that passes through that point that splits our graph into two symmetrical curves. So our axis of symmetry is where x equals 1. Now let's look for the x-intercepts. So this is where our y values are 0. So I'm going to have one x-intercept at 0, 0, which is our origin here. And my other x-intercept is at 2, 0. And now let's talk about end behavior. So let's look to the left of our axis of symmetry. So as x approaches -infinity, our y value approaches -infinity. And then as x approaches +infinity, our y value approaches -infinity still. Our end behavior should be the same for every quadratic function. So because this is a downward facing parabola, our end behaviors, our y value should be approaching -infinity on both sides of this parabola. Let's look at example 4 here on our practice problems. So go back to the table function, clear it out, and enter in 3x² plus 12x plus 9. Now, if your calculator is set like mine, and it's starting at 1, you're going to see where x is 1, y is 24. That goes way off our graph. So let's look at some reasonable values here. Let's start off where x equals -4. So where x equals -4, y equals 9. Where x equals -3, our y value is 0. Where x equals -2, our y value is -3. Where x equals -1, our y value is 0. And where x equals 0, our y value is 9. So let's plot these points. So x is -4. So I'm going to go to the left 4 and then up 9. Then I've got -3, 0, so that's just left 3. I've got -2, -3, so that's left 2 and then down 3. -1, 0, so left 1. And then I'm going to stay there on that x-axis. And I've got the point 0, 9, so just up 9 points. And there's our parabola. Our y-intercept is where x equals 0. So in this case, it's at 0, 9. That's also our c value from our standard form of this quadratic function. Now let's find our vertex. Because this is opening upwards, our vertex should be our minimum point here, which is at -2, -3. Our axis of symmetry is going to pass through that point. So it's the vertical line that passes through that point. So that's where x equals -2. And our range in this case is going to deal with our lowest value coming from our vertex. So in this case, it's going to include -3. And continue on to positive infinity because both sides of this parabola are approaching positive infinity. You could also write this as y is greater than or equal to -3.